Hello dear students, in this video I'll continue with the solution to Arihant sample paper 11. In this video I'll solve the remaining sections, that is section C, D and E of this sample paper. First we will see the questions from section C. Here each question in this section it is of 3 marks. A group of 5 patients treated with medicines P weigh 10, 8, 12, 6, 4 in kg. Then second group of 7 patients treated with medicine Q weigh 14, 12, 8, 10, 6, 2 and 11 in kg. Comment on the rejection of hypothesis significance level 5%. So here we have first a group of these 5 patients and their weights who are treated with medicine P, and next we have the next 7 patients who are treated with medicine Q and their weights. We have to see whether there is any significant difference between the average weights of these two groups. So this is 2 independent sample t-test. So let us define null hypothesis H0 and alternate hypothesis H1 as follows. Null hypothesis H0 is there is no significant difference between the means of, that is the average weight of these two groups, that is H0 is mu1 equal to mu2. And the alternate hypothesis H1 is mu1 not equal to mu2. Next we have, thus a two-tailed test is applied under H0. We have T is equal to x bar minus y bar, or let us take x1 bar minus x2 bar, x1 bar minus x2 bar upon SP into root of 1 by n1 plus 1 by n2. Now we know that SP it is given by root of n1 s1 square plus n2 s2 square upon n1 plus n2 minus 2. Here we can see that the sample data is given. As a result, for n1 s1 square we can write it as s1 square is nothing but 1 by n1 summation x1I minus x1 bar the whole square. As a result, n1 s1 square will be this, n1 s1 square will be summation x1I minus x1 bar the whole square. So from this we will get the pooled variance as summation x1I minus x1 bar the whole square plus summation x2j minus x2 bar the whole square upon n1 plus n2 minus 2. So here first we have to find x1 bar, then x2 bar, then we have to find the pooled variance SP, and then only we can find the value of T, and then only we can compare the critical value with the calculated value and check whether we can accept or reject H0. So here let us have x1I and here x2I. So the various values are 10, 8, 12, 6 and 4, and here we have 14, 12, 8, 10, 6, 2 and 11. So here we have sigma x1I. Now when we add all these, we will get it as 40, and this sigma x2I, x2j, when we add all these, we get it as 63. As a result, x1 bar it is sigma x1I upon n, n1. Here the number of patients it is 5 and sigma x1I is 40, so this is 40 by 5 which is 8. And next we have x2 bar, it is sigma x2j upon n2. So this, when we add all these, it is 63 and the total number of patients is 7, so this is 9. Now we have to find x1I minus x1 bar the whole square. So here x1I minus x1 bar the whole square. x1 bar is 8. So here we have 10 minus 8 the whole square 4, 8 minus 8 whole square 0, 12 minus 8 4 the whole square 16, 6 minus 8 whole square it is minus 2 the whole square 4, Then 4 minus 8 the whole square is minus 4 the whole square, 16. And next let us find x2j minus x2 bar the whole square. x2 bar it is 9. So here we have the first is 14, 14 minus 9 is 5, 5 the whole square is 25, then 12, 12 minus 9 is 3 whole square 9, then 8 minus 9 minus 1 whole square 1, then 10 minus 9 is 1 whole square 1, then 6 minus 9 is minus 3 whole square 9, then 2 minus 9 is minus 7 whole square 49, and 11 minus 9 is 2 whole square 4. So here this total, when we add all these, we will get it as 40, and this when we add all these, we will get it as 98. So we can find SP as root of sigma x1i minus x1 bar the whole square, it is 40, then plus sigma x2j minus x2 bar the whole square, that is 98 upon n1 plus n2 minus 2. So it is 5 plus 7 minus 2. So this is 138 upon 10, or it is root 13.8. So when we find the square root of 13.8, we get it as approximately 3.71. So we have SP as 3.71. Now we have got x1 bar, x2 bar, SP, and we know what is n1 and n2. All these we can substitute in T. Let me continue here. So T is equal to x1 bar minus x2 bar upon SP into root of 1 by n1 plus 1 by n2. x1 bar we got it as 8 and x2 bar as 9, SP as 3.71. So here we have 8 minus 9 upon 3.71 into root of 1 by n1 is 5 plus 1 by n2 is 7. So this is minus 1 by 3.71 into root of, here we have 7 plus 5 by 7 into 5. So it is 12 by 35, or this is minus 1 by 3.71 into root 35 by 12. So root 35 by 12 it is approximately 2.92 upon 3.71. So here again we have to find square root. Square root of 2.92, we get it as 1.7. So it is minus 1.7 upon 3.71. This is equal to minus 0.46. Therefore, we have the calculated value of T as minus 0.46. Here it is given the critical value of T for 10 degrees of freedom and 5% level of significance, it is 2.228. This is a two-tailed test. So here the total area, that is the total region of rejection, is 5%. So here we have 0.025 and here we have 0.025. So this is minus 2.228 and this is 2.228. Now this value T equal to minus 0.46. It lies in the region of acceptance. As a result, we will accept H0. Since T equal to minus 0.46 lies in the interval minus T 0.025 to T 0.025 for n1 plus n2 minus 2 equal to 10 degrees of freedom. That is the value is, that is minus 2.228 to 2.228. We accept H0. Now since we accept H0, we can conclude that there is no significant difference between the mean weights of patients treated with medicine P and medicine Q. So here we have the conclusion. Hence we conclude that there is no significant difference between the mean weight of patients treated with medicine P and those treated with medicine Q. So here this is a question for 3 marks. Here writing the null and alternate hypothesis carries 1 mark, finding the value of T carries 1 mark, and then the result and conclusion carries 1 mark. Next question, find the maximum value of Z for the problem. Maximize Z is equal to 2x plus y. Subject to the constraints x plus y less than or equal to 2, x greater than or equal to 0 and y greater than or equal to 0. So this is a very easy question. We just have to draw this line x plus y equal to 2, then find the feasible region. So here we have only one constraint, x and y. So first let us draw the line corresponding to x plus y equal to 2. When x is 0, y is 2, and when y is 0, x is 2. Then the other lines are x is equal to 0 and y is equal to 0. So here if we draw the graph, this is the line corresponding to x plus y equal to 2. And the region corresponding to x plus y less than or equal to 2, it is this part. And next we have the non-negative constraints. X greater than or equal to 0, it is this part. And y greater than or equal to 0, it is this part. So the region which is common to all these, that is the feasible region, it is this region. So this is the feasible region. So in this feasible region, the corner points are O 0, 0, then A 2, 0 and B 0, 2. So at these corner points, let us find the maximum value of Z. At these corner points, let us find the value of Z, and among the values, whichever is highest, that is the maximum value. So we have the corner points O 0, 0, then A 2, 0, and then B 0, 2. And we have Z is equal to 2x plus y. When x is 0, y is 0, this is 0. Then next for A 2, 0, when x is 2, y is 0, we have Z as 2 into 2, which is 4. And next we have B 0, 2. When x is 0, y is 2, we will have 0 plus 2, it is 2. So among these, the maximum is 4. Therefore, maximum value of Z equal to 4. This is maximum. And occurs at A 2, 0. Therefore, x is equal to 2, y equal to 0 is the optimal solution for this linear programming problem. Next question, Anand Prasad borrows a sum of rupees 2,25,000 at an interest rate of 10% flat for a tenure of 5 years. Calculate his EMI. So here we have to find EMI using flat rate method. So the principal amount borrowed, that is the loan amount, is 2,25,000. The rate of interest, it is 10% and it is flat rate, and the tenure is 5 years. So first let us write what is given here. P equal to rupees 2,25,000. Then the rate of interest, it is 10% or it is 0.1. Therefore the interest amount, interest I, it is equal to P into I into the number of years, 5. So it is 2,25,000 into 0.1 into 5. So this, when we simplify, we will get it as 1,12,500. And next we have the number of payments. Number of payments, it is repaid in 5 years. So in each year there are 12 months. So n is 5 into 12, which is 60. Now we can find EMI R is equal to P plus I upon n. Here P is 2,25,000. I we just now calculated, it is 1,12,500 upon n is 60. So this is 3,37,500 upon 60, or it is equal to 5,625. Therefore, EMI equal to rupees 5,625. So this is the EMI. Next question, a sum of rupees 75,000 invested at R% compounded quarterly will provide payments of rupees 800 each at the end of 3 months. Find the value of R. So here this rupees 75,000, it is nothing but the present value of perpetuity of rupees 800, which is payable at the end of each month when the rate per period it is R%. So here we have to find the value of R. So here given present value P, this is equal to rupees 75,000. And here the rate of interest is given as R. The rate of interest, it is already given as R%. Since interest is compounded quarterly, we have I is equal to R by 4. And then the periodic payment R, it is given by capital R, it is given by rupees 800. So we have the present value of perpetuity given by P is equal to R by I. Here we can see that the payments are made at the end of each 3 months, that is the end of each quarter. So we have P equal to R by I. P is 75,000. This is equal to R is 800 upon I is R by 4. So from this we get 75,000 into R by 4. If we cross multiply, we get this as equal to 800. So here these two zeros will go. When we divide by 4, 187.5. So from this we will get R as 8 upon 187.5. So this, when we simplify, we get it as 0.0427. Therefore, R is equal to 4.27%. So this is the answer for R. Moving on, next question. A population grows at the rate of 10% per year. How long does it take for the population to triple? Use differential equation for this. So here it is given the population grows at the rate of 10% per year. So in the population growth model, that is, we will derive this. We have P equal to lambda into e raised to kt. In this, k is given as 10%. The growth rate is 10%. So we have to find the time taken for the population to triple. That is the time taken for P to become 3 times lambda. So first let us derive the model. Let P be the population at any time t. Then we have dP by dt, it is proportional to P. From this we have dP by dt, it is equal to the constant of proportionality k into dt. So we have k into P. So we have dP by P, this is equal to k dt. Now let us integrate both sides. This implies log P equal to kt plus c. Now this is to the base e. From this we get P is equal to e raised to kt plus c, or P is equal to e raised to kt into e raised to c. When t equal to 0, or let us take at t equal to 0, P equal to lambda, implies lambda equal to e raised to 0 into e raised to c. So from this we will get e raised to c as equal to lambda, that is lambda equal to e raised to c. Therefore, P equal to lambda into e raised to kt. So this is the required population growth model. Now we are asked how long will it take for the population to triple. So here they have given k as it is 10%, that is 0.1. When P equal to 3 lambda, 1 implies 3 lambda equal to lambda into e raised to 0.1 t. So these two will go. Let us take log on both sides. We get log 3 to the base e. It is log e raised to 0.1 t, or this is 0.1 t into log e to the base e. Log e to the base e, it is 1. So from here we get log 3, the value is given, it is 1.0986. This is equal to 0.1 into t. From this we have 1.0986 upon 0.1 equal to t. Or we get t is approximately equal to 10.986. I'm sorry, t is equal to 10.986, or it is approximately equal to 11 years. So the population will triple in 11 years approximately. So this is a question for 3 marks. So here deriving the model usually carries 2 marks. Then since here the growth rate is given, we just have to substitute in the model and find the answer. So the remaining steps carries 1 mark. Next question. The time series given below shows the number of TVs sold by a company since 2003. So here we have for various years the number of TV. It is not the number of TV sold, the sales. The sales of TV. The sales of TV by a company since 2003. So here it is in rupees 1000. Now we have to find the linear equation that describes the trend in the number of TV sold. So here we have to find the linear trend equation that describes the trend in the sale of TV. And also we have to estimate the sale of TV in 2014. So this is here the number of years is, it is 10 years. So for these 10 years data, we have to find the best fit linear equation which describes the trend. So here let us draw a table like this. So all these years I have written here, and these values they are written here. So here we have year and then y, and then next we have x as year minus, here the number of years is even. So here we have to shift the origin to 2007.5, then divided by 0.5. As a result, for 2007 we will get the value of x as 2007 minus 2007.5 upon 0.5. So here minus 1. Then for 2006 it is minus 3, 2005 it is minus 5, 2004 it is minus 7, and 2003 it is minus 9. Similarly here we will have for 2008 it is plus 1, 2009 3, 2010 5, 2011 it is 7, and 2012 it is 9. And next we have x square and then xy. X square it is 81, 49, 25, 9, 1, 1, 9, 25, 49, 81. And next we have xy. Xy we have to multiply these two. 42 into minus 9. So it is minus 378. Then 50 into minus 7. Minus 350. And then 61 into minus 5. It is minus 305. Then 75 into minus 3. It is minus 225. Then 92 into minus 1, minus 92. 111 into 1, 111. 120 into 3, 360. 127 into 5, 635. 140 into 7, 980. 138 into 9, 1242. So let us find the sum of all these. So here summation y, this when we add we get it as 956. Then summation x square, this when we add we get it as 330. and then summation xy, we get it as 1978. Here we add all these things and then minus of, we add all these things and then we subtract. So as a result we will get summation xy as 1978. Now let us find a, b and the equation of trend line. We have a equal to summation y by n. So it is 956 upon 10, which is 95.6. And then we have b as summation xy upon summation x square. So it is 1978 upon 330. This, it is approximately equal to 5.99. Therefore, the equation of trend line it is given by yt equal to a plus bx. That is, yt equal to a is 95.6 plus b is 5.99x. And next we have to estimate the sale of TV in 2014. So here in place of x we have to put, let me write it here. So here in place of x we have 2014 minus 2007.5 upon 0.5. So this will be 6.5 by 0.5, which is 13. Sales of TV in 2014 is y 2014. This is equal to 95.6 plus 5.99 into, in place of x we have 13. That is 2014 minus 2007.5 upon 0.5. So it is 6.5 by 0.5, which is 13. So this, when we simplify, we get it as approximately 173.52. Therefore, sales in 2014 equal to rupees 1,73,520. So this is the sales. Here it is given in rupees 1000. So this is the total sales in 2014. So here drawing the table carries 1 mark, then finding the equation of trend line after finding A and B carries 1 mark, and finding the estimated sales carries 1 mark. Total of 3 marks. Moving on, 2 cards are drawn successively with replacement from a well shuffled pack of 52 cards. Find the probability distribution of number of aces. So here this is a very simple question. Here since it is with replacement, we can use the binomial distribution. So let us take, let x be the number of aces obtained in these 2 cards. So here the various values which x can take are either there will be no ace at all, or there will be 1 ace, or the 2 cards will be of ace. And here n is, it is equal to 2. Now the probability of success, it is probability of drawing an ace. So probability of success P, it is equal to, here among these 52 cards we have 4 ace cards. So probability of success P, it is 4 by 54 or it is 1 by 13. And then probability of not getting an ace, it is the probability of failure, which is Q, it is 1 minus P. So it is 1 minus 1 by 13, which is 12 by 13. So we here, to find the probability distribution of number of aces, we have to find the probability when x is equal to 0, then x is equal to 1 and x is equal to 2. So here x follows binomial n comma p. N is 2 and p is 1 by 13. Therefore, probability of x is equal to r, it is given by NCR, P raised to R, Q raised to N minus R. First, let us find probability of x is equal to 0. Probability of x is equal to 0, it is 2C0, then P raised to 0, and then Q raised to N minus 0, that is 2 minus 0, it is 2. Here 2C0 is 1, 1 by 13 whole raised to 0 is 1. So this is 12 by 13 the whole square, which is 144 upon 169. Next we have probability of x is equal to 1. It is 2C1, 1 by 13 whole raised to 2 minus 1. Then 12 by 13, 1 by 13 whole raised to 1. Then 12 by 13 whole raised to 2 minus 1, which is again 1. So here 2C1 it is 2. 2 into 12 by 13 square. So this is 24 by 169. Next we have probability of x is equal to 2. It is 2C2, 1 by 13 the whole raised to 2, 12 by 13 the whole raised to 2 minus 2, which is 0. So here this is 1. 2C2 is 1. Here 1 by 13 the whole square, it is 1 by 169. So the probability distribution of x So here we have x and here we have probability of x. The various values which x takes are 0, 1 and 2. Then probability of x is equal to 0. We got 144 by 169. And then probability of x is equal to 1. It is 24 by 69, 169. And next we have probability of x is equal to 2. It is 1 by 169. We can also cross check whether we have got this probability distribution right or not by adding all these probability values. If we add all these, we should get this as equal to 1. So here the denominator is 169. The numerator it is also, when we add all these, it is 169. So here the sum of all these, it is equal to 1. So we can also cross check whether our probability distribution is correct using this condition. So here finding the probability of success, probability of failure and writing the distribution, all these carries 1 mark. Then finding the value of each of the probabilities carries 1 mark, and drawing the probability distribution table carries 1 mark. A total of 3 marks for this question. Moving on, next question. A die is thrown again and again until 3 sixes are obtained. Find the probability of obtaining third 6 in the 6th row of a die. So here it is given, a die is thrown again and again until 3 sixes are obtained. We have to find the probability of third 6 in the 6th row of a die. So here let us assume, first let us find the probability of 2 sixes in first 5 rows using binomial distribution. So we have 6 rows. So here first let us find the probability of obtaining 2 sixes in these 5 rows by assuming that x is the number of sixes obtained in 5 rows of a pair of die. After that we can find probability of third 6 in the 6th row by probability of x is equal to 2 in this into probability of getting a 6 in the 6th row. So while doing it will be easy to understand. So here first we are finding the probability of getting 2 sixes in the first 5 rows. As a result, we are taking x as the random variable, which is the number of sixes obtained in 5 rows of a pair of die. So here we have n is equal to 5 and the probability of success, it is probability of getting a 6. So in a row of a die, probability of getting a 6, it is 1 by 6. And then probability of not getting a 6 is the probability of failure q, it is 5 by 6. Therefore, x follows binomial with parameters 5, 1 by 6. Therefore, we have probability of x is equal to r successes. It is NCR, P raised to r, Q raised to n minus r. Now let us find probability of x is equal to q, because that will give the probability of getting 2 6 in the first 5 rows. So probability of x is equal to 2. It is 5c2. It is 5c2. Then p raised to 2. That is 1 by 6 the whole raised to 2. And q raised to 5 minus 2. That is 5 by 6 whole cube. So this is 5 into 4 upon 2. Here 5c2, if you recall, it is 5 factorial by 2 factorial into 3 factorial. Or this is 3 factorial into 4 into 5 upon 2 factorial into 3 factorial. So this 3 factorial and this 3 factorial will go. As a result, here we have 5 into 4 by 2. So 5c2 is 5 into 4 by 2. Then here into 1 by 36 into 125 upon 6 cube, it is 216. So this is 9. Now this, when we simplify, we get probability of x is equal to 2. 5 into 125, it is 625 upon 216 into 2 into 9, it is 3888. So this is the probability of getting 2 6 in first 5 throws of a die. So probability of third 6 in the 6th row, it is equal to probability of getting 2 6s in first 5 throws into probability of 6 in 6th row. That is the third 6 in the 6th row. That is the third 6th. So this is nothing but probability of x is equal to 2. So this is probability of x is equal to 2 into probability of getting a third 6 in the 6th row. This is nothing but it is 1 by 6. This is probability of just getting a 6. So this is 625 upon 3888 into 1 by 6. Now this, when we multiply, we get it as 625 upon 23,328. So this is the probability of getting third 6 in the 6th row. This is the required probability. So here again, writing what is x, writing what is p, q, and writing the distribution up to this carries 1 mark. And then finding probability of x is equal to 2 carries 1 mark. And then finding the probability of getting third 6 in 6th row, all these steps, and the final answer carries 1 mark. A total of 3 marks for this question. Now moving on to the next section, which is section D. In this section, each question carries 5 marks. Anil wants to invest at most 12,000 rupees in bonds A and B. According to the rules, he has to invest at least rupees 2,000 in bond A and at least rupees 4,000 in bond B. If the rate of interest in bond A is 8% per annum and in bond B is 10% per annum, then to maximize the interest, find the investment in bond A and B. So here we have the amount which Anil has got, it is rupees 12,000. So this 12,000 he has to invest in bonds A and B. And then it is given he has to invest at least rupees 2,000 in A and at least 4,000 rupees in bond B. The rate of interest in bond A, it is given as 8% per annum, and in bond B it is 10% per annum. We have to find the investment in bond A and B to maximize the interest. So here this is a linear programming problem. So let the investment in bond A and B be rupees x and y respectively. Rupees x and rupees y respectively. So here we have to maximize the interest. So maximize interest z is equal to the interest on bond A, it is 8%. So if x rupees is invested, the interest will be 8% of x. 8% of x plus, and interest on bond B is 10%. The amount invested is rupees y. So interest will be 10% of y. So this is 8 by 100 x plus 10 by 100 y, subject to the constraints. And next we have the constraints. He has to invest at most rupees 12,000 in bonds A and B. So x plus y should be less than or equal to 12,000. And then he has to invest at least rupees 2,000 in bond A. So x greater than or equal to 2,000. Then at least rupees 4,000 in bond B. Y greater than or equal to 4,000. And then the non-negative constraints x comma y greater than or equal to 0. So these are the three constraints. Now let us solve this linear programming problem. So let us take the graph. So here we have maximize z is equal to 8 by 100 x plus 10 by 100 y, subject to the constraints x plus y less than or equal to 12,000, x greater than or equal to 2,000, y greater than or equal to 4,000, and x comma y greater than or equal to 0. So first let us draw the line corresponding to x plus y equal to 12,000. X plus y equal to 12,000. So here when x is 0, y is 12,000, and when y is 0, x is 12,000. So let us take a graph sheet, mark the x-axis, y-axis, and then let us take 1 unit equal to, 1 centimeter equal to 1000 units. So it is 3,000, 4,000, then 6,000, then 8,000, 10,000, and then 12,000. Here also 2,000, 4,000, 6,000, 8,000, 10,000, and 12,000. So here we have 0, 12,000 and here 12,000, 0. If we draw a line joining these 2 points, we will get the line corresponding to x plus y equal to 12,000. So this line should come here. Now x plus y less than or equal to 12,000, it is the half plane containing the origin. So it is this part. This is x plus y less than or equal to 12,000. And next we have x greater than or equal to 2,000. X is equal to 2,000. It is a straight line passing through 2,000, 0 and parallel to the y-axis. So this is the line x is equal to 2,000. X greater than or equal to 2,000. It is the other side of the origin. So it is this part. This is x greater than or equal to 2,000. And next we have y greater than or equal to 4,000. It is a straight line passing through 0, 4,000 and parallel to the x-axis. So this is y equal to 4,000. Y greater than or equal to 4,000. It is the half plane which is not containing the origin. So it is this part. So the region which is common to all these. And then we have the non-negative constraints. X greater than or equal to 0, y greater than or equal to 0. X greater than or equal to 0, it is this part, and y greater than or equal to 0, it is this part. That is the first quadrant. So the feasible region, it is this. This is the feasible region. So let us mark the corner points of the feasible region. This is one corner point A, this is next corner point B, this is next corner point C. Here we can see that the coordinates for A, it is 2,000, 4,000. And the coordinates for corner point B, it is 8,000, 4,000. And for C, the corner points are 2,000, 10,000. So these are the corner points for A, B and C. Since we are drawing it on a graph, we can directly get the points from the graph. Now we know that since the feasible region is bounded, the maximum value of z will occur at one of the corner points. So here the feasible region ABC is bounded. So we can find the maximum value of Z using corner point method. Z is 8 by 100x plus 10 by 100y. So first we have the first corner point A 2000 comma 4000. So this is 8 by 100 into 2000 plus 10 by 100 is 1 by 10. 1 by 10 into 4000. So this is 400 plus 160, which is 560. Next we have the next corner point B 8000 comma 4000. So again this is 8 by 100 into 8000 plus 1 by 10 into 4000. So it is 640 plus 400, it is 1040. Next we have the next corner point C 2000 comma 10,000. So again we have 8 by 100 into 2000 plus 1 by 10 into 10,000. So it is 160 plus 1000, it is 1160. So among all these, this is the maximum. So here we can see that the maximum value of Z, it occurs at C 2000 comma 10,000. As a result, to maximize interest, we have to find the investment in bond A and B. So to maximize interest, rupees 2000 must be invested in bond A and rupees 10,000 must be invested in bond B. So this is the result. So here according to this year's sample paper, formulation of the given linear programming problem carries 1.5 marks, drawing the graph carries 2 marks, then finding the value of Z at the corner points and writing the result carries 1.5 marks. A total of 5 marks for this question. Moving on, next question. A machine is bought for rupees 3,20,000. Its effective life is 8 years, after which its salvage value would be rupees 25,000. It is decided to create a sinking fund to replace this machine at the end of its effective life by making half-yearly payments that will earn an interest of 8% per annum compounded half-yearly. If it is known that the cost of the machine increases by 5% per annum, calculate the amount of each payment to the sinking fund. Given all these values are given. So here we can see that a machine is bought for rupees 3,20,000. Its effective life is 8 years and its salvage value at the end of its life will be rupees 25,000. So here sinking fund is decided to be created in which half yearly payments are made where the interest earned is 8% per annum compounded half yearly. And here one more information is given is the cost of the machine increases by 5% per annum. We have to calculate the amount of each payment to this sinking fund. So here first let us find the cost of the machine at the end of 8 years. Then from that if we subtract the salvage value, that will give us the amount to be accumulated in the sinking fund. Based on that amount we can find the size of each half yearly payment. So here let us take let R be the amount set aside at the end of every 6 months. And now let us find the cost of machine after 8 years. Now it is 3,25,000. It is given the cost of the machine increases by 5% per annum. Since it increases by 5%, so at the end of 8 years it will be 3,20,000 into 1 plus 0.5 the whole raised to 8. So this is using the formula future value is equal to the present value into 1 plus r the whole raised to n. So this is 3,20,000 into 1.05 the whole raised to 8. It is given here 1.4474 into 4774. So this when we multiply we will get it as rupees 4,72,768. So this will be the cost of the machine after 8 years. And now salvage value of the machine, it is given as rupees 25,000. So amount to be accumulated in the sinking fund. A, it is nothing but this cost minus the salvage value. So it is 4,72,768 minus 25,000. So this, when we subtract, we get it as 4,47,768. So this is the amount to be accumulated in the sinking fund. Now here this is the amount to be accumulated in the sinking fund. So we have the sinking fund formula. We have taken, let R be the amount set aside at the end of every 6 months. So we have A equal to R into 1 plus I the whole raised to n minus 1 upon I. And then here I is, so the sinking fund is created where it will earn an interest of 8% per annum compounded half yearly. So I is 8% divided by 2, it is 0.08 by 2, which is 0.04. I is 0.04. And then n, the number of payments it is. So here we can see that the amount is set aside at the end of every 6 months for 8 years. So n is 8 into 2, 16. So from this we have A is 4,47,768 equal to R into 1 plus 0.04 the whole raised to 16 minus 1 upon 0.04. Now this, when we cross multiply 4,47,768 into 0.04, we get it as 17,910.72. This is equal to R into 1.04 whole raised to 16. The value is 1.873. 1.873 minus 1. So from this 17,910.72 equal to R into 0.873, or R is equal to 17,910.72 upon 0.873. So this, when we divide, we get it as 20,516.28. Therefore, rupees 20,516.28 should be set aside at the end of every 6 months. Therefore, R is equal to rupees 20,516.28. This is the amount that has to be set aside. It is better if we write one line after this. Rupees 20,516.28 should be set aside at the end of every 6 months. Moving on, next question. Find the adjoint of the matrix A equal to -1, -2, -2, 2, 1, -2, 2, -2, 1, and hence show that A into adjoint of A equal to determinant of A into I3. So this is a simple question. We just have to find the adjoint of A and we have to show that A into adjoint of A, it is equal to determinant of A into I3. So first let us find adjoint of A. So given A is equal to -1, -2, -2, 2, 1, -2, 2, -2, 1. So adjoint of A, it is nothing but it is the transpose of the cofactor matrix. So first let us find cofactors of each of the element. So A11, it is the cofactor of this element. It is obtained by -1 the whole raised to 1 plus 1 whole square into determinant of 1 -2 -2 1. So this is 1 minus 4, which is -3. Then we have A12. It is -1 the whole raised to 1 plus 1 whole cube to determinant of, we have to delete the first row and the second column. So it is 2 minus 2, 2, 1. So this is minus of 2 plus 4, it is minus 6. Then A1, 3, it is minus 1, the whole raised to 1 plus 3, 4. You have to delete the first row and the third column. Determinant of 2, 1, 2 minus 2. So it is minus 4 minus 2, which is again minus 6. Similarly, we can find the cofactor of the other elements. Cofactor of A21, it is minus of, we have to delete the second row and the first column and then find the determinant. So it is minus 2, minus 4. So it is minus of minus 6, which is plus 6. Then we have A22, we have to, it is minus 1, the whole raised to 4, it is plus. So we have to delete the second row and the second column and then find the determinant. So minus 1 into 1 is minus 1, minus of minus plus 4. Minus 1 plus 4, it is 3. Next we have A23, it is minus of, we have to delete second row and the third column and then find the determinant. So it is 2 plus 4. So this is minus 6. And next we have A31. A31, delete third row first column, it is minus 1, the whole raised to 4, it is positive. So minus 2 into minus 2, 4 plus 2, 6. Then A32, it is delete the third row second column, this is minus of, minus 1 into minus 2 is 2, then 2 plus 4 is 6, this is minus 6. Then A33, it is plus, delete the third row third column, it is minus 1 into 1 minus 1, then minus of minus plus 2 into 2, 4. So this is 5. Minus 1 plus 4, it is 3. So here adjoint of A, it is the transpose of this cofactor matrix. So it is transpose of minus 3, minus 6, minus 6, then 6, 3, minus 6, then 6, minus 6, 3, the whole transpose. So this is the first row becomes the first column, the second row becomes the second column, and the third row becomes the third column. This is adjoint of A. Now we have to show that A into adjoint of A is equal to determinant of A into I3. So we have to multiply A and adjoint of A. A into adjoint of A is minus 1, minus 2, minus 2, 2, 1, minus 2, 2, minus 2, 1. Adjoint of A minus 3, 6, 6, minus 6, 3, minus 6, minus 6, minus 6, 3. So this is first row, first column, 3 plus 12 plus 12. Then first row, second column, minus 6 plus 12. Then first row, third column, minus 6 plus 12 minus 6. Then second row, first column, minus 6 plus 12. Second row, second column, 12 plus 3 plus 12. Then second row, third column, 12 minus 6. Then third row, first column, minus 6 plus 12 minus 6. Then third row, second column, 12 minus 6 minus 6. Third row, third column, 12 plus 12 plus 3. So this is 12 plus 12, 24 plus 3, 27, 0, 0, 0, 27, 0, 0, 0, 27. So this is 27 into I3. And now if we find determinant of A, it is minus 1 into, here 1 minus 4 minus 3 plus 2 into 2 plus 4 6 minus 2 into minus 4 minus 2 minus 6. So this is 12 plus 12 plus 3. This is equal to 27. So this is A into adjoint of A. So this is 1, this is 2. If we take 1 and 2 implies A into adjoint of A equal to determinant of A into I3. Since we have determinant of A as 27, so this is determinant of A into I3. Hence, we have proved. Moving on, the R part of the same question, using properties of determinants, solve the following for x. So determinant of this A plus x, A minus x, A minus x, then A minus x, A plus x, A minus, this is equal to 0. We have to solve for x. So we have to perform some elementary operations in this determinant and find the value of x. So here given determinant of A plus x, A minus x, A minus x, then A minus x, A plus x, A minus x, A minus x, A minus x, A plus x. This is equal to 0. Now let us apply C1 changing to C1 plus C2 plus C3. So we will get all these becomes A plus x plus A minus x plus A minus x. So we will get 1 x will go, we will get 3A minus x. A minus x, A plus x. This is equal to 0. Now we can take this 3A plus x common from the first column. Taking 3A minus x common from C1. So it is 3A minus x into determinant of 1, 1, 1, A minus x, A minus x, A plus x, A minus x, then A minus x, A plus x. This is equal to 0. And now let us apply R2 changing to R2 minus R1. And then R3 changing to R3 changing to R3 minus R1. So we will get 3A minus x into R2 changing to R2 minus R1. So 1 minus 1, the first row will remain the same. Then 1 minus 1 will become 0. Here A plus x minus A plus x. So here we will get 2x. And here A minus x minus of A minus x, here again it will be 0. Then R3 changing to R3 minus R1, again this will be 0. 1 minus 1, 0. And here A minus x minus of A minus x, this term will be 0. And then A plus x minus A plus x, here we will get 2x. This is equal to 0. Now we can expand along C1. Expanding along C1. So 3A minus x into 1 into 4x square. And then minus 0. Then all the other terms will be 0. So this is equal to 0. So from this we get 3A minus x into 4x square equal to 0. From this we get x is equal to 0 or x is equal to 3A. Therefore, x is equal to 0, 3A. This is the solution for this. Now moving on to the next question. The demand and supply functions for a commodity are, this is R, P equal to x square minus 6x plus 16, and so this is the demand function and this is the supply function, x square by 3 plus 4 by 3x plus 4. Find the consumer surplus at the equilibrium point when x less than 7. So here when we have a question like this, here they have given when x is less than 7. So in this case we will be getting more than one value for x. We have to take only that value which is less than 7. So here the demand and supply functions are, the demand function is given as PD equal to x square minus 6x plus 16, and the supply function PS is equal to x square by 3 plus 4 by 3x plus 4. Now at the equilibrium, demand and supply are equal. PD equal to PS implies x square minus 6x plus 16 equal to x square by 3 plus 4x by 3 plus 4. Let us transpose all the terms to the one side, and I am collecting all those terms with x square first, then with x first, then after that with x minus 6x minus 4x by 3 plus 16 minus 4 equal to 0. So here the LCM is 3. 3x square minus x square, it is 2x square by 3. And then here if we take the minus sign outside, it is minus of 6x plus 4x by 3. So this is LCM is 3. So it is 18x plus 4x by 3. So here we have minus 22x by 3 plus 16 minus 4 is 12. This is equal to 0. So let us divide the entire part by 2. We will get x square by 3 minus 11x by 3 plus 4 equal to 0. Plus 6 is equal to 0. So here we have 3 as the LCM. So we will get x square minus 11x plus 18 equal to 0. Therefore, the quadratic equation in x is x square minus 11x plus 18 equal to 0. Now this we can factorize as x square minus 9x minus 2x plus 18 equal to 0. So x into x minus 9 minus 2 into x minus 9 equal to 0. So the factors are x minus 2 and x minus 9. This is equal to 0. So x is equal to 2 or x is equal to 9. So from this we get x naught is equal to 2 since x less than 7. Now we can find the value of P by substituting x naught as 2. This implies P naught is equal to, I am substituting in this demand function, x square minus 6x plus 16. 2 square minus 6 into 2 plus 16. So it is 16 plus 4, 20 minus 12, 8. So x naught is 2 and P naught is 8. Now consumer surplus, it is given by integral 0 to x naught. Demand function dx minus P naught x naught. So this is integral 0 to x naught is 2. Integral 0 to 2. Demand function, this is the demand function. X square minus 6x plus 16 dx minus P naught x naught, 8 into 2. So this when we integrate we get x cube by 3 minus 6x square by 2 plus 16x with the limits 0 to 2 minus 8 into 2, 16. So the upper limit it is 2. When we substitute 2 here, we have 2 cube by 3. So it is 8 by 3 minus 3 into 2 square. So 3 into 4, 12 plus 16 into 2 is 32. 32 minus 16. So this is 8 by 3 plus 4. 32 minus 16, 16 minus 12 is plus 4. So this, if we take LCM, we will get it as 8 plus 12. So this is 20 by 3. Therefore, consumer surplus equal to 20 by 3 units. So this is consumer surplus when x is less than 7. Moving on, next question. They are part of the same question. Evaluate integral x upon x minus 1 the whole square into x plus 2 dx. So here this we have to integrate using partial fractions. So let us take, let I equal to the given integral. I equal to integral x upon x minus 1 the whole square into x plus 2 dx. So first let us make the partial fraction decomposition. Let x upon x minus 1 the whole square into x plus 2 equal to a by x minus 1 plus b by x minus 1 the whole square plus c by x plus 2. So from this we get x is equal to a into x minus 1 into x plus 2 plus b into x plus 2 plus c into x minus 1 the whole square. Or this is a into, here we have x square, then minus x plus 2x. So x square plus x minus 2 plus b into x plus 2 plus c into x minus 1 the whole square is x square minus 2x plus 1. So as a result we have x is equal to, here coefficient of x square is a plus c plus coefficient of x is a plus b minus 2c plus the constant term is minus 2a plus 2b plus c. Now we can equate the coefficients of x and constant term on both sides. X square and constant term. Equating coefficient of x square, x and constant terms. So we will get a plus c equal to 0, then a plus b minus 2c equal to 1, then minus 2a plus 2b plus c equal to 0. Here we can see that the coefficient of x square on the left hand side is 0, so this is 0, and the constant term on the left hand side is also 0, so this is also 0. So from here we will get a equal to minus c. So this, when we substitute here, we will get minus 2a plus 2b. Now here it is plus 2c. 2c plus 2b plus c equal to 0. And from here if we are putting a as minus c, so it is minus c plus b minus 2c equal to 1. So from here we will get b minus 3c equal to 1, and from here we will get 2b plus 3c equal to 0. So if we add these two equations, we will get 3b equal to 1. 3b equal to 1 implies b equal to 1 by 3. Now this b equal to 1 by 3 we can put it in this equation. So we will get 2 by 3 plus 3c equal to 0, or 3c equal to minus 2 by 3, or c equal to minus 2 by 9. And here we got a equal to minus c, so a it is plus 2 by 9. A equal to 2 by 9, b equal to 1 by 3, and c equal to minus 2 by 9. So these are the values of a, b and c. So this we can substitute for a, b and c, and then we can integrate very easily. So I is equal to 2 by 9 integral 1 by x plus 1, dx by x minus 1 plus 1 by 3 integral dx by x minus 1 the whole square minus 2 by 9 integral dx by x plus 2. So integral dx by x minus 1 is log mod x minus 1 plus 1 by 3 into integral dx by x minus 1 the whole square is, it is x minus 1 the whole raised to minus 2 plus 1 upon minus 2 plus 1. So it is minus 1 by x minus 1. Here minus 2 plus 1 will be minus 1. So this will be minus 1 by x minus 1. So here we have minus 1 by 3 into 1 by x minus 1. Then minus 2 by 9 log mod x plus 2 plus c. So this is the integral of this function, or we can combine these two. Since here we have 2 by 9 common, so this is 2 by 9 into log a minus log b, it is log a by b. 2 by 9 into log mod x minus 1 upon x plus 2 minus 1 by 3 into x minus 1 plus c. So this is the integral of this function. Now moving on to the next section, section E, which consists of case study questions. Subham is rowing a boat. He takes 8 hours to row 48 km upstream, whereas he takes 4 hours to go the same distance downstream. Based on the above information, answer the following questions. So here it is given the time taken to go 40 km upstream is 8 hours and time taken to go the same distance downstream is 4 hours. Using this, we have to find the answer to all these: speed of boat in still water, speed of stream, then average speed of Subham, and then after that we have another situation given. For that we have to find the answer. So let me do it here. So here let us take, let the speed in still water be x km per hour and the speed of the stream be y km per hour. So we know if the speed of the boat in still water is x and speed of the stream is y, then speed of the boat upstream it is x minus y km per hour and speed of the boat downstream is x plus y km per hour. The distance d here it is given 48 km. So time taken to go 48 km upstream, it is given as 8 hours. Now this time taken to go 48 km upstream, this is nothing but distance by speed. So it is 48 upon x minus y. This is equal to 8. So here this will go 6 times. So from this we get 6 is equal to x minus y if we cross multiply, or we will have x minus y equal to 6. And next we have, it is given time taken to go 48 km downstream, it is 4 hours. This is given as 4 hours. But using the formula distance by speed, time taken to go 48 km is distance upon downstream speed. Downstream speed is x plus y. This is equal to 4. So these two will go 12. So from this we have 12 is equal to x plus y, or we have x plus y is equal to 12. So let us take this as 1 and let us take this as 2. So we got x plus y as 12 and x minus y as 6. So now we shall solve each of the subdivision. Speed of the boat in still water. If we add these two equations, adding 1 and 2, we will get x minus y plus x plus y equal to 6 plus 12. So minus y plus y will go, we will get 2x is equal to 18 or x is equal to 9. Therefore, x is equal to 9 km per hour. That is speed of boat in still water. This is equal to 9 km per hour. Then the second subdivision, we have to find the speed of stream. Speed of stream, we can either subtract these two and find, or we know that this is the downstream speed and this is the upstream speed. So speed of the stream, it is given by downstream speed minus upstream speed by 2. It is 12 minus 6 by 2, which is 6 by 2, 3 km per hour. So this is the speed of stream. And now we are asked to find the average speed of Subham. We know that the average speed, it is calculated as total distance by total time. So here the total distance is, he goes 48 km upstream and 48 km downstream. So it is 2 into 48 upon total time is 8 plus 4. 8 plus 4. So it is 2 into 48 upon 12. So this is 4. This is equal to 8 km per hour. So the average speed is 8 km per hour. Next we will see the R part of the same question. The stream is flowing at the rate of 6 km per hour. If Shubham rows a certain distance upstream in 4.5 hours and returned to the same place in 2.5 hours, then what is the speed of Shubham's boat in still water? So here the speed of the stream is given, and here he rows a certain distance upstream in 4.5 hours and same distance downstream in 2.5 hours. We have to find the speed of the boat in still water. So here let us take, let the speed in still water be x km per hour and let the distance be d km. Then the speed of the stream, it is given as 6 km per hour. And then the time taken to go d km upstream, it is given as 4.5 hours. Now this time taken to go d km upstream, it is nothing but d upon x minus y, that is x minus 6. This is equal to 4.5. And next we have time taken to go d km downstream. It is 2.5 hours. Now this 2.5, it is nothing but the time taken to go d km downstream, which is d upon x plus 6. That is the downstream speed. This is equal to 2.5. So let us take this as 1 and 2. Let us divide 1 by 2. We will get d by x minus 6, the whole thing divided by d by x plus 6. This is equal to 4.5 by 2.5. Or we will get d by x minus 6 into x plus 6 by d equal to, this is 45 by 25, or it is 9 by 5. This is equal to 9 by 5. Here d and d will go. We have x plus 6 by x minus 6 equal to 9 by 5. Here we can cross multiply. 5x plus 30 equal to 9x minus 54. So here let us transpose this minus 54 to the other side. So we will get 84 equal to 9x minus 5x, which is 4x. From this we get x is equal to 84 by 4. It is 21. Therefore, x is equal to 21 km per hour. So this is the speed of the boat in still water. Therefore, speed of boat in still water is 21 km per hour. So here this is a question for 2 marks. Moving on. Next we have the last case study question. Let x be the random variable which count the number of hours a student of class 12 studies. X has a probability distribution P of x of the following form. So here probability of x, it takes values k, 2k, 3k. When x is 0, 1 and 2 respectively, it takes zeros otherwise, where k is a constant. So based on this above information, we have to answer the following questions. So we have to find the value of k, value of expectation of x, then value of expectation of 2x square, or variance of the distribution. So let us do each one separately. Similar questions we have seen so many times. So it is a very easy question. The probability distribution of the random variable x, it is given by, here we have x and here we have probability of x. This is x equal to xi and this is equal to pi. So the various values which x takes are 0, 1, 2 and otherwise any other values. When x is equal to 0, probability is k, x is equal to 1, probability is 2k, and when x is equal to 2, probability is 3k. Otherwise it is 0. First we have to find the value of k. Since summation pi equal to 1, this implies k plus 2k plus 3k equal to 1, or we get 6k equal to 1. From this we get k equal to 1 by 6. The second subdivision, we have to find the value of expectation of x. Expectation of x, it is summation xi pi. So it is 1 into k. K we got 1 by 6 plus, 0 into, first it is 0 into k. K we got 1 by 6, then plus 1 into 2k. K we got 1 by 6, so plus 1 into 2 by 6, then plus 2 into 3k. 2 into 3 by 6. So here this is 1 by 3. This is 1. So it is 1 plus 1 by 3, which is 4 by 3. Therefore, expectation of x, it is equal to 4 by 3. This is the expectation of x. And next we have expectation of 2x square. The third subdivision, expectation of 2x square. Now we know that expectation of ax, it is equal to a into expectation of x, or we can write it here itself. This is equal to 2 into expectation of x square. The reason, since expectation of ax equal to a into expectation of x. So as a result, this we can write it as 2 into expectation of x square. So this is 2 into 0 square into the probability, or it is 2 into sigma xi square pi. This is 2 into xi square, 0 square into 1 by 6 plus here 1 square into 2k, 1 square into 2 by 6 plus here 2 square into 3k, 2 square into 3 by 6. There is 1 2 outside. So this is equal to 2 into, here this is 0, here we have 1 by 3, here let us have 6 by 3. So 1 by 3 plus 6 by 3. So this is 2 into 7 by 3, which is 14 by 3. Therefore, expected value of 2x square, it is 14 by 3. And now the R part of the same thing, it is, we have to find the variance of the distribution. So the variance of the distribution, variance of x, it is given by expectation of x square minus expectation of x the whole square. If we are not attending this question, then we have to do this question. For this, we have to find expectation of x square. But expectation of x we have already found in this second subdivision. So that we can substitute here directly. So expectation of x square is summation xi square pi minus expectation of x square is summation xi pi the whole square. So this is summation xi square, 0 square into k, it is 1 by 6 plus 1 square into k, we got 1 by 6. It is 1 square into 2 by 6 plus next we have 2 square into 3 by 6. 2 square into 3 by 6 minus summation xi pi, we already got expectation of x here, it is 4 by 3 minus 4 by 3 the whole square. This is from 2. So here this becomes 1 by 3 and here 1 3. So it is 1 by 3 plus 6 by 3 minus 16 by 9. So here if we have the LCM as 9, it is 3 plus 18 minus 16. So this is 5 by 9. Therefore, variance of x, it is equal to 5 by 9. So this is the variance of the distribution. So this question carries 2 marks. So these are the various questions in sections C, D and E of Arihant sample paper 11. I hope this video was useful for you. If you have not subscribed to my channel, please subscribe. I have already made videos on the previous year questions and questions from sample papers on each chapter. The link is available in the description. I wish all the students all the best for your exams. Thank you for watching.